Hello friends, welcome back to the data structure tutorial. Today we will be discussing about queue using array. As queue is also one of the important data structure in the to manipulate the data, and as I have mentioned that queue is also a linear data structure. It means that whatever data we will be dealing with, that will be in the linear format or in the ordered format. And the working principle of the queue is first in first out. Now to understand this concept first in first out, let us take an general example which I have mentioned here, few examples from the daily life, that people standing in a row for bus ticket on a counter. Let's say this is our ticket counter, and people are standing in a row to get the ticket. So suppose this is a first person which is standing in a row, and next person obviously will be standing behind him, the next person again behind him, and the row will be formed. Now the first person is the one who is arriving the very first time, and once he get the ticket, obviously he will coming out of the row. Then the second person is coming, he will take the position of the first one, and again he will receive the ticket and he will get out of the row. And if someone new person wants to take a entry to this row, so he or she has to enter through this end only. Okay. So the person who is coming first is getting the ticket and getting out first, and the person who is coming at the end will be the added to the queue from the behind. So the person which is coming first, that is first in, that will be come out first, that is a first out. So first in first out is the working principle of queue. And in the next point I have mentioned that operations on the queue can be done through both ends. So you can see that the deletion means the person who is leaving the row, which is from the front, and the person who is entering into the row is from the rear end. So operations are happening through the both ends, that is the front end and rear end. So that is our next point. The insertion into the queue is done through rear end, means the insertion is from the rear end, and the deletion is from the front end. So let us understand this with some other example, like printing pages from your queue. So where this queue can be used, suppose you have a n number of pages in your computer, and this is your first document, second document and third document, or the 3 pages of a same document. Whenever you print it, so obviously the first page will be printed first, then second page will be printed, and then third page will be printed. So the sequence is maintained. So first page is coming to the printer first, so it will be printed first, then second, and then third. So it is maintaining the row, that is a queue, and the element which is coming first will be taking first out, so that it can achieve the property of queue. Now let us talk about the example using array. So as we know that queue is a linear data structure, so we'll take one array and we'll name that array as a queue with certain size. For this example we are taking the size is equals to 4, so size is 4 here, and indexing is starting from 0 to 3. So obviously the size -1 is the last location where you can enter. Now suppose user wants to add something into this queue, so we have named that queue as a queue, and we'll add one more index which will representing your current front and rear. So initially front and rear is at -1, and as per the definition the insertion will be done onto the rear end. So if user asks you to insert one new element, for example user wants to insert A, so at which end you will insert? At the rear end. But rear end initially is at -1, so you have to bring him to the 0th location. So you will bring him here, this is the rear location, and you added the first element. So as A is a first element, you have to bring front to this location as well. So front and rear will be at the location 0. Now if user is asking you to insert another element, that is insert B, so obviously A is there, insertion is done through the rear end, so rear will be shifted to this location, and at this location you will be adding B, and now who is the front? Front will remain to the location 0 with pointing to the element A. Now suppose user wants to add 2 more elements, so user can add suppose insert C, and insert D. So this will be A, B, C and D. So this will be your rear end, which is the last added element, and this will be the front end because you are not deleted any element yet. Now user wants to add one more element. So if user wants to add one more element, so from which end he will add? He will add only to the rear end. But as per the size of the array, we have already inserted 4 elements, so there is not a possibility of adding the new element. So how do we know that the new elements entry is not possible? Suppose user wants to add the element insert E. So that is not possible. Why? Because the your rear, the position of the rear is equals to the size minus 1, size minus 1. And what is size? Size is a 4, so 4 minus 1 it is 3, and your rear is also standing at third location. So that's why the new element cannot be inserted. So that is what I have mentioned here, that is Q full condition is when rear is equals to the size minus 1, then you cannot insert the new element. Now same way, whenever you perform the deletion operation, so whenever you want to perform the deletion operation, so let us assume that we have already 4 elements and we want to delete an element. So suppose you deleted the element, so from which end we perform the deletion operation, and we have mentioned that deletion is performed through the front end. So if user wants to delete an element, so A will be deleted because which is pointing to the front. So once you delete the A, so let us consider this. Let me clear this. Now suppose user wants to delete, so user will call delete function. Now automatically front will be deleted, so 0th position will be deleted, the element will be deleted and front will be shifted to the next location and the remaining elements are there. Now suppose user again called delete function second time. So what will happen? B will be deleted, front will be shifted. And again if user called delete multiple times, delete, delete and delete. Now what happened for this delete? C will be deleted, front will be shifted. For this delete, D will be deleted and front will be shifted. Now where is the front? By the logic, front will be at 4th location, which is not a part of your queue. And now user is calling delete again. So there is a no element to delete, right? Where is your rear end? Rear was at the third position. Here I have not mentioned, but it is at the third position because that was the last element. So now whenever you call delete multiple times and somewhere you deleted all the elements, so automatically front gets higher position than the rear. So whenever you get the front, the position of the front greater than the rear, what it means? You do not have any element to delete anymore. So it is your empty condition. So that is what we have mentioned here. The Q empty condition is when front is greater than rear, means you are deleting the element, deleting so that the front is moving forward than the rear. That case will be the empty condition for the queue. And what is the another condition? Suppose your front and rear is at -1 initially and you want to delete, so there is a no element, so how you can delete the element? So that is not possible. So that is another condition. When front is equals to -1 means there is a no element to delete. So you need to check these two conditions while performing the operations on queue. Now let us write algorithm for insertion and deletion from the queue. So let us consider that we have a function insert which will receive one data and we have to check. So while insertion data, what condition we need to check? We need to check whether the place is available or not, whether the size is full or not. So how will you check it? If the position of rear is equals to size -1. So what it means? Your queue is full, you do not have any place. Else if this is not the condition, you have to increment the position of rear. So rear is equals to rear plus 1, and on that position of your q, means on the rear position you will be adding your data. And as you are entering the first element, so we considering that the front and rear will be at -1 initially. So if the front is equals to -1, it means that this is your first element. So what you will do, you will be incrementing front by 1 only once. This will executed only once for the first element, and then you will be closing your else and function. So this is an algorithm for insertion of the element into the queue. Now let us talk about the another element, one function. That function is delete. So in the delete function, we have to check one condition whether the elements are available in the queue to delete or not. So how will you check it? So there are two conditions. One, when your front is equals to -1, means you have not entered any element, or the second condition is you are deleted so many elements so that front is greater than rear, means the position of the front is greater than rear. So in that case there is no element to delete, so you will display one message that is empty. Else if it is not the case, you want to remove the element from which end? Front end, because deletion is carried out at the front end. So you will write from the front of queue you will be copying the data, suppose x, in the x variable you copied the data, and now front should be move ahead. So the front is equals to front plus 1. So automatically front will be incremented to the next position. So this will be the algorithm for deletion of the element from the queue. Now let us implement this with the help of Java. So here I have already created one folder, DS tutorial. I will quickly create one file whose name will be suppose demoq.java. Here we will create one class for the main method, that is demoq, and here I will be writing public static void main and string arguments. Okay, and before writing the logic, we will create one another class, and I will be naming that class as queue operations. So this class will be maintaining the operations on queue. Okay, so here we need one array of particular size. So I will declare one variable size, and I will define that size as suppose 5 elements. Then integer array whose name will be suppose q is equals to new integer, and what size you want, the size which we have mentioned. Then few temporary variables we need, for example data, so I will declare that as well. So let us create one function for insertion. So you will write insertion or insert, and this function will be receiving one data, that is integer data. Okay, and for the insert you have to check the condition of full. So what is the full condition? So here you will write if rear is equals to size minus 1. Okay, so we forgot to declare this variable rear and front. So I will declare here rear, which will be integer -1 initially, and front will be also at -1 initially. So if rear is equals to size -1, so what message you want to print? So we want to print a message that queue is full and go back. So return. Else if this is not the case, so what it means? We have to add the element which we have received, this one, to the rear end of the queue. So queue inside this array at the rear end add your data. Okay, but before that from -1 to the 0 we have to move the rear end. So you will write rear is equals to rear plus 1. So you are incrementing the rear end from -1 to 0, and at that 0th location you will be entering your data. And you have to check one more condition. If it is a first element, So how do you know that it is a first element? So if front is equals to -1 means it is your first element and you will be incremented front by 1. This will be only executed for once for the very first element. And then here we'll just print one message to understand the user that data is inserted, and what data you have inserted, just print that data. So this is for the user interaction. Now after this function, I'll create another function whose name will be suppose delete, and we'll be checking the condition if, what condition you need to check while deleting the element, that deletion will be done at front end. So if front is equals to -1 means there is no element, or front is greater than rear. So if one of these conditions satisfies, so we'll tell the user that your queue is empty, there is no element to delete, just go back, that is return. Else if this is not the case, then what you will do, you will extract the data from the queue's front, because deletion will be carried from the front. So front data you copied, then you have to move forward to the front. So you will moving front to the next location, and for understanding the user you will print some message that data is deleted, and what data you have deleted, just print that data. Okay. Now to display the entire queue, we'll create another function. We have just implemented the algorithm of delete. Then we'll create another function whose name will be suppose display, and here you have to check to display whether we have data or not. So how do you check it? So again, front is equals to -1 means there is no data, or if the front is greater than rear means you have deleted all the data and you do not have anything to display. So again you will mention that queue is empty and you will return. Else if there is something to display, so how will you display it? So you have to start from the front to the rear end. So sorry, I missed the spelling. Okay, so for from where you will be starting, from integer I is equals to front, okay, till you will go to the rear end. That's why I less than or equals to rear, and I plus plus, so that every time you will be incrementing the position. And here you have to print your element from the queue. What element? Ith element. So it will be printing your queue, and here I'll just display one message for understanding that queue is, so that after that message you will be getting your queue. Okay, so we have just written algorithm for insert converted into the program by just adding some user interactive statements, then algorithm for the deletion, and this is a display function, and now we want to call them. So everything which we have written is present in the another class, and name of that class is queue operations. Create one object is equals to new queue operations, so that you can call the functions. So how will you call? op dot, the name of the function is insert, and provide some data. So we'll provide some random data 34, op dot insert. I'll provide 45, op dot insert. I'll provide some random data, op dot insert some more data. So we have a size 5, so at least we have to enter 6 elements, so that we'll get the message of full. So I'll enter 66 and op dot insert, for example 21. So the size is 5, which we have defined size earlier is 5, and we are sending how many elements? We are sending total 6 elements. So after insertion of 66, it should not accept the 21, and it should display a message that your queue is already full, you cannot insert the 21. So how will you check it? By calling the display function. Now let us compile it. I am compiling it manually. So java c demo queue dot java, and you can write java demo queue. So you can see that it has inserted the element till 66, data inserted up to 66, and 21 it is not accepting, it is giving you the message queue is full, and when you call the display function it is displaying one message queue is 34 to 66. So according to the definition, 34 which we have inserted first, it should be at the front end and 66 should be at the rear end. So whenever you call the delete function, so by the definition deletion will happen from the front end, so 34 has to be deleted, right? So let us check by again displaying after deletion. Let us compile it again and run it. Okay, so here you can see that we have inserted 34 to 66, 34 is at the front. When you call the delete function here, so 34 is deleted, which was at the front, and the remaining queue is printed. So likewise, if you try all the conditions, then you will see that we have successfully implemented the algorithms of queue. And if you want to do it manually, so you can apply the do while and switch cases, and you can give a choice to the user to call the respective function and accept the values. So I hope that all of you have understood this queue in the data structure. We'll see you in the next video.